In the previous video, part 1 of this series, we integrated 1 over 1 plus tan x dx. As a first step, we just converted the tangent into cosines and cosines by multiplying through by cosine in the numerator and denominator, and we got our integral to this second piece right here, second step. Then in the third step, here we manipulated our integral so that we had something in the first integral that is 1, because we've got the same denominator and numerator. So you can see this here is 1. And then we manipulated the second integral into something where we could use a u substitution, because the derivative of this denominator is actually the numerator. So we were completely set up for a u substitution. In this video, we're going to do, we want the same idea. We want to have something that's going to be easy to integrate, because we have 1 here and a u substitution for the second one. But I'm going to say, what if we didn't quite know what these coefficients were? What if the coefficients weren't 1? What if it was a little more difficult? What if we just didn't know that trick for separating this integral out this way? What we could do is we could say we want it to be in this form, but we just don't know what these coefficients are. And then we can go about solving for those coefficients. Because we know what the numerator should be. We can't change that, that's what it is. So what we could do is we could multiply these coefficients into our integral, and then we have an equation that we could solve. So first I'm just going to multiply this through, so we'll have a cosine of x, a sine x, doing this first piece, and then with the second piece we'll have b cos x minus b sine x, and I didn't really give myself enough room, but this whole thing is going to equal 1 cos x. And really what I want to say is we're going to have 1 cos x and we're going to have 0 sines. And what that's going to do is it's going to allow us to split this equation up and split the sines from cosines. So we'll look first at just our cosine terms. So we're going to have we'll write a plus b cosines equals 1 cosine. And see, I don't actually need the cosine. There's cosine in every term, so we're just summing up the cosine terms. And then we'll do the same thing with the sines. We have a number of sines, however many that is, minus, not plus, minus b sines here. But then on the right side of the equation, we have 0 sines. So we've got our equation a minus b equals 0. This is a pretty easy equation to solve, so we can just add them together, and we'll have 2a equals 1, which means a equals a half, and you can plug that back in and you'll see that b also must equal 1/2. So what did we just do? We just found those coefficients that we actually, in the first video, we found that through some tricky manipulation, but this is a more systematic way of finding that, and it also will work in more complicated scenarios. So this can be, it's a taste thing, but it can be a better way if you have a more complicated problem. And then of course, to finish this off, we can integrate now that we have everything we want to integrate here. So this is just 1, so we're going to have a half. Integral of 1 is x plus a half. Then here we're saying we're making a u substitution. We're calling this u, and the derivative, let's write it out. So this is u, which is cos plus sine. And let's just take the derivative of u. So du is going to be the integral of cosine x is going to be minus sine x. I'm just writing it in order to show that it's going to, how it lines up. And then the derivative of sine x is going to be cosine x. And so we notice that our du is exactly what we have up here in the numerator. So when we rewrite this integral, we're going to have, we have our half x plus a half du over u. But then when we integrate this, the integral of du over u is just ln of u. Ln of absolute value of u. I think I'll just squeeze this in down at the bottom. So rewriting this, we have a half x plus a half ln, and then plugging in our u, we're gonna have cos x plus sine x plus c. And that's it. So that's the second part. So in the third part, the last video, we're gonna change the problem a little bit, and I think that'll maybe show you why the second method is useful in a slightly different situation.